Hi, everybody, and thanks for joining the Net Zero Building video series from Canadian Contractor. I am very pleased to be joined by Victor Hyman. He is the executive director from ClimateCare. They are a cooperative of residential HVAC contractors. Victor, how are you doing?
Fantastic, Patrick. Thanks so much for having me on today.
So we're going to have a conversation today, or Victor's going to have a conversation, and then we're going to have a conversation about heat pumps. Basically, the question is acceptance and how this technology is going to be moved into homes and all of our projects. Really, as we go forward, there's lots of legislation and incentives, building code changes that are basically pressing in that direction. And you know what? With the state of the technology today, as Victor is going to go into, it may be just something we all want to do anyways. So I'm gonna let Victor take over. He's got a short presentation for us here, and then we'll have a little chat about this. So take Victor, please introduce yourself and what ClimateCare does, and then take us into your material.
Fantastic. Thanks so much, Patrick. So, as Patrick said, my name is Victor Hyman. I'm the executive director of ClimateCare. We are Canada's largest cooperative of residential HVAC contractors. And we've been around since 1992. So we've been around for a long time, focused in Ontario and looking to grow nationally. What makes us a little bit different is we're a cooperative. So think Home Hardware, not Home Depot. We're 30 independent contractors, and the cooperative corporation, which I run, supports those member contractors in providing the best solutions to their customers. So residential decarbonization is something that we're passionate about, not just because our name is ClimateCare, but because we think that it's the right thing to do for our customers and for you. So let's talk about residential decarbonization and 2030, which of course is the plan to move things forward in the new construction space. And 2050 is the long-term goal. We're going to focus on retrofit contractors and how we move away from like for like replacement. So very common in our space to go out and see a 4-star gas furnace and an air conditioner and provide a quote for replacement. And I think in the renovation space, when we're talking to GCs, similar kind of thing happens. That house had a furnace and air conditioner. Maybe you have a boiler for some in-floor. And when that house is being planned for a retrofit, energy conservation doesn't typically go top of mind in many cases. People that generally want to do a new house, they're thinking about their countertops, they're thinking about the new stonework that they're going to do, maybe the new windows and the curb appeal, but the stuff that gets buried in the basement, we don't typically think about. So my challenge for you today is to think a little bit differently, and how can we deliver a product for our customers that's going to future-proof them and give them the best home comfort possible. So back in 2018, the federal government, you can see there the Energy and Mines Ministers Conference, put together something called the Market Transformation Roadmap to Decarbonize the Building Sector. And Canada, somewhere between 15 and 20% of all carbon emissions come from the building sector, and the residential building sector is a significant part of that. So what we're trying to do as a society is figure out how can we decarbonize, and as a building sector, being responsible participants in the building sector, how do we do our part and decarbonize the building sector? So the MTR identified 5 areas of challenge or market barriers, and call those the 5 A's. So availability, accessibility, awareness, affordability, and acceptance. And it's amazing how much has changed in the last 6 years. So does the technology exist? Is it accessible to market participants? Does the market know about the technology? Is it affordable? And does the form, fit, and function of the technology make it acceptable to what we need to do? And back when this was originally done, you'll see that there were a lot of reds and yellows up there. Ground source heat pumps, are available, accessible, and some, people are aware of them, but affordability and acceptance weren't very high. Cold climate air source heat pumps were kind of yellow across the board. Back in 2018, they still weren't as good as they are today. And then gas heat pumps, they look like a dead end in 2018, and they continue to look like a dead end. What has changed? Well, I think even since 2021, we've had some significant changes that have taken place in the market. But in terms of availability and accessibility, cold climate air source heat pumps today are accessible and available across the country. Since 2021 in greener homes, we saw a huge rush into air source heat pumps. That's definitely come up. I think ground source it cooled a little bit because of how strong the cold climate air source heat pumps sales moved. But I think that the economics of ground source continue to be favorable for people who are building a forever home. And so I would suggest that if you've got land, especially if you're building a house or doing a deep reno on houses with acreage, that not looking at horizontal loops and going ground source would be a mistake. That's definitely something that is worth taking a look at. So COVID threw a wrench in the plans back, in going from 2018 to 2021. Certainly, we were all living in our homes 24 hours a day. I don't know if everybody remembers or we've totally forgotten, but it totally messed up the supply chain. And then greener homes came along, and everything kind of got confused for a couple of years. The good news is that we've overcome those. So supply chain issues are solved, lots of product in market, and no problem there. So that's good news. We've moved past that. So what do we want now as a society? Well, again, decarbonization of the residential building sector. I think we want an end to energy poverty, which is that people shouldn't have to choose between gas and groceries. People need to be able to afford heat, and that's become that has been the third rail of politics in many parts of the country, and so we have to be conscious of that. We want quality workmanship, making sure that the product is installed properly, and we want good paying jobs as a society. So I think that when we look at the automotive sector, and this is something that I like to use as an analogy, because I think while we're all in the building sector, everybody owns a car. Many of us own pickup trucks. So this is often a good analogy. And I think what the market is ready for, is that F-150 Lightning on the left, form, fit, function, very similar to a regular F-150, unless you have to tow. There's a proviso there. But for folks that are doing work in town, you're driving under 300 kilometers a day, that looks exactly like your F-150. It's super quiet. It's got Blue Cruise. You don't look like you're doing anything crazy like the Cybertruck on the right. And so I kind of make this analogy to going net zero. That's the F-150 Lightning, and going passive house is the Cybertruck. And so while we do have people who want to look like they're from the Jetsons, most people want to do what is kind of comfortable and normal for them up until now. And so I think the market's ready for going net zero. We're getting pretty darn close to it. So how do you do that? So how do you do it, and how do you avoid this? So this is the innovation curve. I'm sure you've seen this before. Laid on top of the innovation curve is a kind of a bit of a Dunning-Kruger, but we're somewhere near the chasm at this point, actually, in residential decarbonization. Greener homes was pulled in a lot of that early majority. Now that in many provinces those dollars have gone away, I think we've had people sliding back to the lowest opening price point product. And this is really an opportunity, I think, for some market differentiation. People, I think I'm talking to residential contractors working in doing, renovations and custom homes. And you probably are working for people who have a little bit of money and want a better quality product. And so if that is your customer, I'm going to suggest you help future-proof them and deliver a better quality product, and let's move this along past early majority. What are the challenges? Well, I think carbon pricing is a big one. It is certainly a hot potato. It may be, cause for the next election, perhaps. The next federal election, we'll see. But certainly political backlash with higher fuel prices. It exacerbates energy poverty. Is it going to interrupt the plan? I'm not a political theorist, but it seems to me that Kathleen Wynne in Ontario discovered that high electricity prices were a way of losing an election, to the point that in Ontario we still have a 25% subsidy on residential electricity prices. So my sense here is that, the price of natural gas goes up and down. Electricity is a little bit more stable because of the political implications, but it's certainly an issue. We may discover in a year that we no longer have federal carbon pricing. So we have to be able to make an argument for a hybrid or a all electric heat pump system that makes sense economically. Okay, what are the other challenges? Well, workforce development is an issue. The average age of residential refrigeration, air conditioning mechanics in Ontario, it's over 50, it's 58 years old, plus or minus. Many parts of the country are very similar to that. And we need many, many more people trained. Build Force Canada did a study for Enercan this year and found we need 10,000 new residential air conditioning mechanics in the next 5 years. So there's a huge drive to retrain and upskill the existing workforce. HRAI, that's the Heating, Refrigeration, Air Conditioning Institute, the industry advocacy organization, is going through a what's the exact term? Skills gap analysis funded by Enercan to understand what is the skill gap between somebody who's currently a gas technician and needs to become a residential air conditioning systems mechanic. And that is ongoing, but needless to say, there's going to be some upskilling of the workforce necessary to ensure that heat pumps are installed properly. Why is that different than installing air conditioners? Heat pumps run at higher pressures in heating than in cooling. And so higher pressures means that there needs to be greater workmanship in the quality of brazing or mechanical connections that are made in line sets. And we have to pay closer attention to vacuuming those line sets, making sure that in the course of installation, we really get a deep vacuum to avoid acid production and contamination when we're running at very cold temperatures and high pressures. So organizations like Support Ontario Youth and St. Lawrence College and Women in HVAC have been really involved in helping to find creative ways to overcome the workforce development issue and get more people into the trade properly trained quickly. Here's another challenge. Most HVAC replacements are emergencies, and they happen when it is really hot or really cold. And so retrofit options need to be in stock, and contractors, they have to be able to make the case for doing something different. That's why we're having this conversation today. Most consumers are not interested in paying more upfront or over time. They want, not only what's the lowest upfront cost, but the lowest lifetime cost. So this requires some education as we move people away from what they've been doing. I think, again, the opportunity talking to retrofit or contractors involved in retrofitting homes, not just on the HVAC side, but you're doing other things while that home is being retrofitted, means it's probably a great opportunity to do the HVAC system. And you have the opportunity to modify ductwork and all kinds of things that make it more difficult in just an HVAC re-and-re. I mentioned about making sure we have the right stuff on the shelf. This goes back to 2021, 2020, and a huge increase in air conditioning sales. I don't know if anybody remembers what happened in 2021 that drove those air conditioning sales like crazy. It was the heat dome in Western Canada, right? Alberta and British Columbia, and places where they didn't used to have air conditioners, all of a sudden installed air conditioners. Absolutely a necessity, but unfortunately what was installed was an air conditioner, not a heat pump. And so that's a 15-year decision, a 15-year lost opportunity. We're not going to change that product out until it's ready to be replaced. If they had installed a heat pump, then they would be future-proofed essentially as things change. So I think it's really important for you to be thinking about the future. And again, as a retrofit contractor, where you're really doing that whole home reno, you have the real opportunity to guide your customer into making a decision that if this is a home they're planning on living in for more than 5 years, that what's the incremental cost really? Maybe it's zero, maybe it's negative. Let's look at something that's going to future-proof you. So let me give you a few examples of what this looks like. What are we supposed to do with this house? This is a 90-year-old semi on a 20-foot lot in downtown Toronto. The customer wants to get off fossil fuels. Contractor wants to earn a sale and a happy customer. got 100%, sorry, a 100 amp electrical panel that's maxed out. We have an existing mid efficiency 60,000 BTU furnace. The ductwork only supports 1100 CFM. Calculations show it's only got a 43,000 BTU heat loss and a 19,000 BTU heat gain. So, you could risk it and go with a 40,000 BTU furnace and a 1.5 ton AC. I think it's more common. What we would see here is a 60,000 BTU furnace and a 2-ton AC, just to be safe. And this is where I really want to caution you on the just to be safe. Oversizing is not just being safe. It is not the right thing to do. This house, getting the heat loss and heat gain down is not going to be too hard. It's 90 years old. So if you're going in there and you're opening up walls and you're improving the air sealing and insulation, you're going to get this house down below 40,000 BTU. And probably the heat gain would stay actually about the same. So we're challenged again. We've got 1100 CFM to play with, which means that we could install a heat pump with, a 3-ton, we'd be pushing a 3-ton heat pump, but certainly a 2.5-ton heat pump would work in that application. And what we really need to start looking at and working with a HVAC contractor that can, or designer that understands is, when we're talking about a cold climate air source heat pump, we're talking about a product that modulates, right? So we've got an inverted compressor. It can ramp up and ramp down. There are a few things we want to be careful of, like making sure the minimum modulation is going to satisfy the cooling load. We're not going to be, running at an output that's going to make it very hard to cool the house effectively and dehumidify. We want to make sure also that we're not going to run into problems around defrost. And, that's an issue that we want it to be running in the defrost window, which is like +2 degrees Celsius, +3 degrees Celsius, 47 degrees Fahrenheit is where the potential for defrost first starts, which is 8 degrees Celsius, and going down to about, -3, -4 degrees. That's what the defrost window. So we want to make sure that the heat pump isn't going to short cycle in that. Probably getting a little bit too deep into the weeds for renovation contractors. So suffice it to say, there's some stuff that your HVAC contractor needs to know, and that's very important. What are the challenges? I think giving contractors confidence in that we can do this. Lots of money, time, and effort has been expended over the last few years to give HVAC contractors the tools to right size the equipment. So you see there the air source heat pump sizing selection tool from Enercan that was developed to help HVAC contractors size the product appropriately. And so those tools exist now, and there are many more tools coming onto the market to help HVAC contractors properly size it. I would tell you at this point, the tools exist. We're working as an industry to train contractors on how to use them. But as a reno contractor, if you're interested in helping your customers future-proof and decarbonize, you want to be looking for an HVAC contractor that's comfortable with these tools and can do it. What we get as an industry, as an HVAC industry, get a lot of feedback from people saying, well, I called a contractor and they told me it won't work. I'll tell you, that's just an HVAC contractor who's just not comfortable with the technology. It does work. It works 100%, no problem, when it's applied properly and you've been trained. How do I know that? Because we've had lots of case studies to show that it's the case. I'm going to show you a couple of case studies here done by the Sustainable Technologies Evaluation Program at the Toronto Region Conservation Authority. These are studies that were done over the last few years. They actually just released a new study of 6 homes in Peel region, which is just to the northwest of Toronto. And you'll see that these are hybrids. So this is a gas furnace, a natural gas furnace with an air source heat pump. And in these cases, in this one that I'm showing you right here, this is what we would consider to be not a cold climate air source heat pump, just a regular 2-stage air source heat pump, 17 SEER, 9.5 HSPF. As they say, it's a medium level heating efficiency. And it was able to decarbonize this house by 51%. The net utility cost savings in space heating is $46 a year. And that was based on, I think, a $50 carbon tax. So at a $65, which is where we're at now, we're heading to 80 next year. The economic argument in many parts of the country favors a hybrid system at the moment. Here's another case. Again, this is low efficiency air source heat pump, and 74% decarbonization. So again, we've got that forced air gas furnace. I think at this point, that's just providing some peace of mind. But this was able to decarbonize 74%, and the savings again, $41 a year. So basically operating at the same cost as an all gas system. This is another one, 65% gas reduction, $64 net utility. Oh, this one actually has an increase. It does happen, $64. What we're not showing here is the savings. If we go to a real cold climate air source heat pump, the savings you're going to have on the air conditioning side. They're typically running 18 SEER and higher. And I can tell you from my own experience, taking out a 12 SEER AC and putting in a cold climate air source heat pump, that my air conditioning bill has dropped dramatically in Toronto year over year. So what all these have in common is really easy like for like replacements, except instead of doing an air conditioner, did a standard efficiency heat pump. Looked exactly the same. And consumers in all of these cases said that the comfort was better with the heat pump than with the gas furnace. The reason for that is actually longer run times. When you run a heat pump, you've got a lower temperature rise and it runs for longer periods of time. So instead of getting that up and down that you're going to get with a single stage gas furnace, you get a more even heat. And that was reported by all of these homeowners. And then this is, a fourth case that the TRCA did going all electric. This is with a Mitsubishi Zuba system. And so this would decarbonize their space heating 100%. In Ontario, in Quebec, in the Atlantic provinces, in British Columbia, in Manitoba, where the grids are relatively clean. Atlantic Canada, that's hit and miss, but your alternative is to burn heating oil. In all of those cases, this is a net win for emissions, because even looking at what the grid is doing, it is a net win. Never mind the efficiency improvement. That one of the arguments that's kind of lost here is people think, well, we're taking all this energy that we're moving through the gas pipeline. How are we going to replace it with electricity? We don't have the electricity capacity for all of that gas. That's true, but we don't need to replace 100% of the gas. We only need to replace about 30% of the gas is energy capacity, because the heat pumps, especially cold climate air source heat pumps, are running at a COP, a seasonal energy efficiency of better than 2.5, 2.5. So they really use a fraction of the energy that the gas furnace uses. That's in an energy conservation side. On a greenhouse gas side, again, in situ, at site, we can decarbonize 100%. Questions can be, what does the grid do? In almost all cases, except Alberta, you will decarbonize, you have a net decarbonization by going with an all-electric system. In Alberta, depends where you are. Lethbridge, Calgary, and Edmonton have really different kind of grid mixes. And it could be that going all-electric will actually produce more carbon emissions today than running a natural gas furnace on site. But I think that's why a hybrid heat pump in those kinds of environments makes a lot of sense, because certainly during the shoulder seasons, when the COP is, the coefficient of performance of the heat pump is very high, 2.5, 3 or higher, it will be better to run the heat pump than run the gas furnace. And you win on the air conditioning side, plus you get better comfort in the shoulder seasons when modulation is really important. Okay, I'm going to just talk a little bit about municipal goals, and this is something that can be a little bit frustrating for us in the industry interested in helping decarbonization move along. There are hundreds of thousands of low-rise homes that we need to convert to heat pumps to decarbonize. It's a lot of work. It's going to take a long time. I don't think we have to do it all at once. I'm not suggesting that, but like I said, it's a 15-year lost opportunity if we replace an air conditioner with an air conditioner. So my challenge to you as reno contractors is, how can you help? How can you help? Well, help your consumers choose a heat pump. This is looking, kind of picking on Waterloo Region here, and the mixed messages that get sent. So in Waterloo Region, they've got 149,000 low-rise homes as of 2016. That was the last available census. 29,870 to be converted to 100% heat pumps by 2030 to meet their goals, their stated goals. That's 4,267 homes a year. I can tell you we are not changing out 4,267 furnaces to heat pumps a year in Waterloo region. It is not happening. But the more compounding problem is that there are 2,245 new single-family semi and row houses built every year in Waterloo region, and they're being hooked up to the gas grid. So, you've got this situation where we're running on a treadmill that's going to shoot us off the back. We just can't do this fast enough if we don't start with the new construction piece. And that's, again, talking to reno contractors, you folks have the opportunity where we're not under the gun to do the system replacement. It's not an emergency. We can help our consumers make that choice. And this is the kind of thing that kind of grinds my gears. Is the easiest house to make carbon free is the new home, right? And if we don't do it at construction or at this reno that you're doing, we may never be able to do it, because when you're opening up the walls, you've got the opportunity to change the ductwork. And I showed you that house, that 9-year-old semi in Toronto, that ductwork can only support 1100 CFM. And so when you open up, if you're doing a reno there, you're going back to the stud, you're opening up the ceiling, that's the time to change the ducts. If we don't do it now, we maybe will never be able to do it again in the lifetime of this home. So I really encourage you, when you have that opportunity to open it up, don't just clean the ducts, size them and understand, can they meet the needs of this house if we go all heat pump? And if they can't, what's the incremental cost, to do this right and deliver a better performing home for consumers. So this is a house, it just kind of kills me, because this was done as a net zero ready home with a gas furnace, and it's a lost opportunity, and maybe will never be decarbonized because I don't know how they've sized the ductwork on this. So what should we be offering today? So that good like-for-like replacement of a furnace and air conditioner, I'm going to suggest we should forget about that. Let's move that off the table. It might have the lowest first cost. If you're installing, builder grade AC and furnace, it's going to have the most expensive life cycle costs, can guarantee. So really having that conversation with your customer, is this your forever home? Are you going to be in this home for more than 5 years? If you are, let's talk about something that's going to deliver you better comfort and better energy efficiency and be less expensive to operate. And so that would be the next one, that better. Let's make that our opening price point: gas furnace and a heat pump. I've got there $2 signs for the first cost. The truth of the matter is that in many regions of the country, there are still incentives when you're doing a renovation to put in a hybrid system, at least. So instead of doing an air conditioner and a gas furnace, if you do the heat pump and gas furnace, you probably qualify for something, or your customer may qualify for some either consumer incentive or financing. So the Greener Homes loan still exists, and that's available, $40,000 10-year interest-free loan. If you do need something that qualifies, hybrids do qualify. So you might be able to help your customer get a $40,000 interest-free loan, which, versus a 5% mortgage, still pretty attractive. And then the best, again, from a decarbonization point of view, and I think really, again, life cycle cost, is that cold climate air source heat pump or ground source heat pump. Yes, it may be the most initially, but it will drive the best value for consumer, best quality of comfort in a fully communicating product that the indoor unit, outdoor unit can work together with a really smart control. Ground source delivers a really fantastic opportunity to decarbonize also the not only space heating, but also water heating side of things. And again, if it's a forever home, could be the lowest life cycle cost, especially with incentives towards 0% interest financing, depending on where you are in the country. So I think that, we have to really think here like a cat. And, what are the obstacles, but what are the opportunities? We could just, you all know the next video, which I'm not going to show you, is the dog running through that and knocking over all the corks. We have to be like the cats here, right? For contractors that are a little bit more progressive in terms of the offerings they offer their consumers, not just going for the lowest opening price point. You want to differentiate yourself around comfort and long-term long-term life cycle costs and decarbonization, there's a real opportunity here to make a recommendation to your consumers that is going to support their needs in the long run and help you have a happier customer. So with that, Patrick, I will stop my share.
Victor, thank you very much. Good presentation. That was really really informative. I think it's a nice blueprint, that all of us in the contracting world can take when we're having these conversations with clients and trying to, suggest to them, maybe not the lowest cost furnace that's available, and maybe trying to set themselves up for the future. One of the things that occurred to me while I was listening to you there was this whole net zero building project is a system of trade-offs, right? It's about the whole house being net zero, and so if there's a complaint about cost on the heat pump side, especially if you're building a custom home, the whole home, but even on a large reno. If there's the complaint on that side, there is the opportunity to still hit those net zero targets because you maybe don't have to pay as much. Perhaps you don't have to put in triple pane windows, right? Because you put a heat pump in there. Is that something that they should think about?
That you really great point. There is no way to decarbonize just through fixing the envelope, right? Unless you change the heat source itself. So I think if we start from the first principle of we want to decarbonize, right, then we have to figure out how to get a heat pump in there. And yeah, the trade-offs, absolutely. Listen, triple pane, best performing window, quietest, right? There are definitely reasons we want to look at getting, the best of everything. But of course, budget is always going to kick in. And I would challenge, I've said this for many years. I can get you a code HVAC system in new construction that will meet code for 5% of the total cost of the project. But it doesn't mean it's going to make you happy. It's not going to make you comfortable. It will meet the code requirements. It'll keep you but if you want a customer that's not calling you in July and complaining that the bedroom upstairs in their master bedroom in their beautiful new home is uncomfortable, that's going to be more than 5%, right? So I think that we have to really be conscious of, you can have the most beautiful home in the world, but you may not want to sleep at night in it because it's just too damn uncomfortable during the heat dome. So really making sure that home comfort is part of the equation. And, yes, we may have to steal from Peter to pay Paul somewhere along the line, but, when we're rationalizing things in the renovation, I think, home comfort is something that we want to be careful about rationalizing that one. And if we're already looking for a system that will deliver better homeowner comfort, then going with a system that will decarbonize is a very small incremental cost.
Yeah. That you bring up the heat dome and the comfort in the upstairs bedroom and all of that. One of I guess it's climate change. I mean, I don't know. We just had 30 degrees here, and it's mid-September for the last week. Whatever. I mean, when I was growing up, no one had air conditioning, right? I didn't have air conditioning. No one had air conditioning in Canada. It just wasn't a thing. Now it always is everywhere. Always have air conditioning in your house. That has got to be a major argument on the heat pump side, right? Like that takes away a lot of those cost evaluations because it's like, well, you're gonna have to use the energy on AC anyways, and this now is helping with both, right?
100%. And this is, I think we ran into a branding issue, a marketing problem in the HVAC industry. We've got air conditioners and we have heat pumps.
Yeah.
And first of all, pump, people think of water, they don't think of heat. So it's already, I remember being in this industry and talking to somebody on the plumbing side. I worked for a national wholesaler, and he thought like a heat pump was like a Taco 007, or a Grundfos. That's what he thought it was, a heat pump. I'm like, okay, I understand the confusion, but I'm actually talking about a thing that looks like your air conditioner. I actually prefer a slightly different phraseology. Now, I say it a little tongue in cheek because I don't think I'm going to change the industry here or the way we talk about it. But, I like to think of air conditioners and heat pumps as we have air conditioners that they only cool, and we have air conditioners that heat and cool. And really, we're conditioning the air. So I don't know why we have to call it something different. One cools. There's nothing that says condition means cooling. Conditioning, when we talk about air conditioning, we're talking about, reducing the latent and sensible loads, right? So heat and humidity. But why can't we be talking about an air conditioner that heats also? So I like to think of it as we have a cooling only air conditioner, and we have a heat cool air conditioner, and functionally they, practically, for practical purposes, they look the same. What's amazing also is that, many of the side discharge cold climate air source heat pumps are so quiet. You gain a huge amount on the air conditioning side, right? It's a much quieter product, much smaller for close lot lines. And so I would, even from an air conditioning standpoint, we have a product, we sell it under the Carrier brand. It's made by Medea, but it is a side discharge cold climate air source heat pump, and it defaults to cooling. So it's a little, I don't want to get too deep in the weeds, but it can be set up as with only 2 wires to the outdoor unit, 2 control wires as an air conditioning product. Because in this case, you energize the reversing valve in heat, which means that it defaults to cooling. Personally, I think it's a fantastic air conditioner as an air conditioning product. And if somebody said to me, I just want an air conditioner, I would say install this, because it's such a good air conditioner on the cooling side. And the truth of the matter is, all you have to do is run 1 more wire and you can use it for heating. So I think that there's a lot to think about there in terms of moving the way we think. And do we have a single function air conditioner, or do we have a dual function air conditioner? And that's the way I really think about it today.
Something else you mentioned, and because I can sometimes like to go down engineering rabbit holes. The old dig on, sorry, I'm going to still say heat pumps, was doesn't work so well when it's very cold. Yeah. And you've mentioned the big advances on the cold climate heat pumps lately. What's changed? What have they done?
Yeah, it's called vapor injection or mid-vapor injection. So what we're doing, I don't have a slide of this I can show you right now, but you can look it up.
We'll imagine it.
You'll imagine it. Basically, what we're going to do is take some hot gas off the compressor and route it back in. And so what that allows the system to do is operate. It raises the head pressure for the refrigeration people out there, right? When the temperature gets very, very low, a head pressure drops, and we're going to inject some hot gas. So hot gas bypass, we inject it back in, and mid-vapor injection, we raise the compression, raise the pressures so that it can operate at lower temperatures. What it means is that we have, coefficients of performance of, better than 1.75, often 1.8, 2.0 at minus 20 degrees Celsius, right? So this is a huge advance where we're running at, now, is it as cheap as gas at that point? No, not in any part of the country.
Right.
Let's be honest. When it's minus 20 degrees, running a gas furnace will be less expensive than running the best air source heat pump. Geothermal will still be cheaper, but the best air source, cold climate air source heat pump. But what we really have to understand is how often does it get that cold? Now, again, if I'm talking to people in Calgary, I've been in Calgary in the winter. I've been there when it did not get above minus 30 degrees for an entire week. It was January 2020, right before COVID. Remember it very clearly. I think I still have the frostbite on my toe. But the reality is that for the vast majority of the Canadian population, that is just not reality, right? So yes, Alberta, very northern Ontario, very northern BC, northern Quebec, I completely agree. Manitoba, there are issues where having backup is going to be essential. 50% of the Canadian population lives along the St. Lawrence River, down through the Great Lakes region. It does not get that cold. Even in Ottawa, I hear the people in Ottawa all the time. How many hours a year do you get to minus 40? It almost never happens. So I think we have to be really, and climate change is driving this. I mean, it's very interesting to look at the models from Environmental and Climate Canada. And we're seeing that we just do not have the sustained deep cold that we used to, and we're having higher temperatures in the summer. So average heating degree days is going down. It's not going up across the country. And you have to really look at what that looks like, because if I can solve you down to -5 degrees Celsius, right, which is what the case studies showed, those systems aren't running below -5 degrees. We're decarbonizing between 50 and 75%, right? And if I can go down to -20, which is what we're doing with a cold climate air source heat pump, then in most parts of the country, not geographically, but where the population is, in most parts of the country, we can get to 100% decarbonization. So I just challenge people to think, don't just go with what you've all, what the revealed wisdom is. Dig a little bit deeper and understand, what does it look like in your municipality, in your locality.
Yeah, that's been that's the big change. It's even if you are paying more to run it at -20 for a week, you get a cold snap, fine. You got to think about the fact that you're doing air conditioning now too, and I believe the air conditioning is a bigger part of a house energy budget now, sort of on average across the country already, than heating, if I'm not mistaken.
I mean, I think again,
It's close.
It's close. It depends where you are, but
Right, right.
So I'll tell you what's interesting in the HVAC business. We talk about the 9 weeks from hell in the retrofit air conditioning business. That basically we sell 80% of our air conditioners in a 9-week period.
Right.
So that traditionally was June and July, and maybe the last week of May and the first week of August, right? And you just think about like when it's hot where you are, right? Yeah. Most of those air conditioners get sold in that 9-week period. And what we're seeing now, I mean, here it is, it's September 19th, 2024 as we're recording this, and it's 25 degrees in Toronto today.
Yeah.
Right? And so my air conditioning is running because it's 25 degrees. It's unusual, but it's becoming the new normal. And so air conditioning loads are becoming more and more significant. And what I'll tell you is, I mean, from my own experience, taking out a 12 SEER air conditioner and putting in an 18 SEER 9 HSPF cold climate air source heat pump, is that I'm saving $60 a month on my air conditioning bill, right? So over the course of, and I don't think it's 9 weeks anymore, I think it's at least 12 weeks, right? So we're talking over a 3-month period. I'm saving, $180, $200 a year on my electricity on the cooling side, which is a huge win.
Yeah. People probably know this, but I don't. What are the ducting differences you need? Like I mean, I know it's project by project, but what's the rule of thumb? Are you generally going to need larger ducting, smaller ducting? I should know this, but I don't.
No, it's a great question, and this is something that it can be easily overlooked. So the duct work is sized for, in most cases, for the heat rise of a gas furnace. So when you think about your gas furnace, and you've got a return air temperature, I'm going to use Fahrenheit because that's what we're an antiquated industry here.
Yeah.
Let's say we've got a return air temperature of 69, 68 degrees Fahrenheit. And we want to raise the temperature in the house to 72 degrees. So the temperature rise that we're looking at is between 40 and 70 degrees Fahrenheit, right? So we're going to heat that air up to at least 120 degrees Fahrenheit. And people are going to put their hands by the grill and it's going to feel, oh yeah, that's warm air. Now, I'll tell you, people don't remember this, but when we went from oil to gas, people complained that it wasn't blowing as hot. And then we went from standard efficiency furnaces to mid-efficiency furnaces, and we would get complaints, it's not as hot as it used to be. And then we went from mid-efficiency furnaces to high-efficiency furnaces, like, I don't feel it anymore. Okay, why is that? Because the heat rise is dropping, right? If you have a house that was built around the heat rise of an oil furnace, you can have very small ducts because you're going to pump out very hot air. But as the heat rise drops, as we extract more and more energy out of the flue gases, and when we get to a high efficiency furnace, we need to condense the flue gases, which means that the products of combustion have to be cooled to about below 120 degrees Fahrenheit to get that condensation, which gets us to over 90%. The temperature's dropped. Okay, what about a heat pump? Well, heat pump output temperature drops even some more. So now we're talking about 105, 110 degrees Fahrenheit. Now, I mentioned the mid-vapor injection. That helps actually not only on helping them run to lower temperatures, but helping to maintain a higher output temperature. So with the current, the current generation of cold climate air source heat pumps, we get less of those complaints about it blowing cold air because the manufacturers got wise to this. So they want to produce a higher output temperature, but we need to move more air than we did with a gas furnace. And so if the gas furnace ductwork is built around, I showed in that example, 1100 CFM at 0.1 inches static pressure, which is kind of the standard, then we're going to be limited to the size of the heat pump we can put in. And typically we're talking about 350 to 400 CFM, cubic feet per minute, for every ton of capacity, which is 12,000 BTU. So this has never really been an issue on the air conditioning side, because in most parts of the country, as I showed you, you've got a 60,000 BTU furnace, and let's call it a 1.5 or 2 ton AC. So that 2 ton AC only needs to move 700, 800 CFM. No problem. The ductwork was big enough. But if I'm trying to size the ductwork now, not for a 24 or an 18,000 BTU air conditioner, but for a 36,000 BTU heat pump, well, 3 tons, now I need to move more like 1,200 CFM, and my 1,100 CFM ductwork just be too small. What is the net effect of that? If I try to push the air through, I'm going to impair efficiency. I'm going to wear out the blower motor in the air handler faster, and it's going to be noisier. And we don't want noisy. People don't like noisy. They want to be quiet. So this is really important to understand that nuance. And I would tell you also, it's a great opportunity to right-size the ductwork to improve the comfort and also the noise. So I had this experience in my house that my furnace was hugely oversized because over the course of the last 20 years, I have made incremental energy efficiency improvements. I changed my windows, from the old single pane, drafty windows to really good double pane windows. I did air sealing. I put it in attic insulation, and I got my heat load low enough that I change out an 80,000 BTU furnace with a 2 ton AC in my own home for a 40,000 BTU 2-stage furnace with a 2 ton cold climate air source heat pump, which actually has a maximum output of 27,000 BTU. When I did the calculations, I determined that actually this heat pump will work in my house down to about -10 degrees, cover at a lower cost than running the gas furnace. At that point, I can transition to the gas furnace stage 1. And for a couple hours a year, I might go to stage 2. It is so much quieter than my old air conditioner because I'm able to run it at a lower CFM. I get better dehumidification. I get more even heat. It's a win all the way around. And in my case, I didn't have to change the ductwork because I had, done that heat loss calculation and concluded that it would fit within the existing ductwork. So again, that may be one thing that comes out, but go and do the work. Have your heating contractor designer do the work, because that's an easy thing to fix in the reno window and hard to fix after.
Good points. Well, listen, Victor, that's all I got, but I want to thank you very much for coming on and telling us all about how to think about heat pumps. That's Victor Hyman from ClimateCare. We're going to put up a slide at the end with his contact information so you can reach out if you have any further questions. But Victor, thanks so much for telling us all about this today.
Thanks so much for the opportunity, Patrick. Have a great day.